Hi everyone and welcome to Coding with Tom. Microsoft has just released .NET 8 and in Blazor there's some amazing new functionality. In .NET 7, when you created a new Blazor project, you had to decide whether your site would have interactivity provided by server or WebAssembly. And once you chose one or the other, your entire project was essentially in that mode. However, in .NET 8, individual pages or even subcomponents on a page can be either statically rendered or rendered using Blazor Server or Blazor WebAssembly for interactivity. This is a major paradigm shift and makes Blazor a much more flexible platform for developing web applications. So I'm going to go over the differences between these rendering modes and provide an example of each and how they can be used together. The first type of rendering mode is called statically rendered components. This is very similar to the way ASP.NET Core works without Blazor. Basically, your Blazor components will render on the first time a page is requested. And you could even have a post with form data to update those components. However, there is no back and forth interactivity with event binding and all of those other things that are nice with Blazor. But this might be sufficient for what you're doing. For example, if you're just displaying a menu, or you have a very simple form input, or you have other static content, then just statically rendering your page is a good option. Your second option is to use server-rendered components. This is similar to Blazor Server in the prior versions, and it uses SignalR to communicate back and forth between the web browser and a representation of your Blazor components that are kept on the server. So in this case, the server components can interact directly with services running on the server, and then user interface changes only are transmitted back and forth via SignalR as a response to user input in the web browser. The last option you have is WebAssembly. So this is similar to the Blazor WebAssembly projects of the past, where WebAssembly is compiled and runs on the client browser. So all the interactivity and user interface updates are done on the client. And then you would create an API client on your web browser in WebAssembly that would connect back to a controller on the server to do updates of data. So most of the work as far as user interface updating and interactivity is done on the client in this case. So this doesn't require as much connectivity between the server and the client to update the user interface like the last option. And as we know from the past, all these different options had their advantages and disadvantages. Now what's great in .NET 8 is that you can mix and match these on pages or sub-components on pages based on the way you'd like to use them. In this video, I'm going to go ahead and make a simple CRUD-based application that will show the use of Blazor Server, Blazor WebAssembly, and the automatic switching between the two, and some of the issues that arise in doing that, and how Blazor has solved them. I'm going to create a new project using the Blazor web app template that is new with .NET 8. What I'm going to do is include the individual accounts for authentication. When it comes to interactive render mode, let me explain the choices. None means there's going to be no interactivity, so no Blazor Server or WebAssembly on any pages. Server means the entire thing will use server interactivity. WebAssembly means the entire project will use WebAssembly, and auto means you can use both, depending on where you want to use them. So I'm going to choose auto. And then as far as location goes, if you make it global, then it's similar to what was available in .NET 7 and before, where it's the entire application. However, I'm going to do per page and per component to allow us to change it based on a page or component level. And this is where the real power of Blazor comes in .NET 8. So let's create this. In the solution, you'll see there are two projects. The top project contains all of the code that runs on the server. The bottom project contains all of the code that will be compiled to WebAssembly and run on the client for any components that you use that will use WebAssembly. Let me give you a demo of the template project. So if I run it, you'll notice there's a new home page which has no interactivity to it. In fact, this entire page is not being rendered at all using any interactivity as far as Blazor Server or Blazor WebAssembly. These are all statically rendered pages at this point, the menu and the hello world. Now when I go to counter, counter is a WebAssembly component. So this portion of the page with the counter is being rendered in WebAssembly. So if I click it, you'll see the counter going up. Now the weather page is rendered on the server, and it uses something called streaming rendering, which I'm not going to go into in this video, but it's very useful because it lets you render a static page, but also have a little bit of the page evolving as it loads the first time. Like this data might take some time to load, so you could have a loading message, and then the data would follow. And as soon as the data is available, it would show up here without doing any server interactivity at all. No WebAssembly or Blazor Server at all. Auth required is just an example of a page that requires you to be logged in. Registration and login are now native Blazor components. They used to be ASP.NET Core Razor pages, but now they're native to Blazor, which is nice. So I'm going to go ahead and register an account for this. Of course, you have to apply your migrations the first time that you start a project because it has to create the database with initial tables. And these initial tables are the same tables in the past, the ASP.NET identity tables. If I refresh the page, it will go back. I'll be able to do it this time. And of course, I can click here to confirm the account since there's no email sender configured. And I should be able to log into the site. And at this point, this auth required page will let us in, and it'll tell us who's logged in. Now you'll notice that if I go to pages here on the client project, the auth page and the counter page both exist in the client project. That means that these are interactive pages that could potentially be run using WebAssembly. Now, what they do on the page is have this attribute that says render mode interactive auto. What that means is the component will actually function using Blazor Server and SignalR when it first loads, and in the background we'll download a WebAssembly. And once the WebAssembly is loaded, it will switch to the WebAssembly. Same for the counter page. Interactive auto is the mode as well. We're going to adjust this later so that we can see the page being run on the server and then on the client and then eventually auto again. So this works just like it did in the past. As far as Blazor goes, we have a button bound to this increment count method, and we have a current count bound to this current count property. And all of this works because of Blazor, initially Blazor Server, which then automatically switches to Blazor WebAssembly once the WebAssembly is loaded. So this example is kind of a simple example. In this video, I'm going to make a more complicated example that will hopefully flesh out some of the more details that you are going to need to take into account when you're developing Blazor apps. The application I'm going to create is going to be a simple app that will allow you to post messages to a board and delete them. So to that end, I'm going to create some additional data for this project, actually just one more table. So let me go to the data folder in the server project. You'll see there's already an application context, and this is an entity framework context that's based on the identity DB context, which contains all the ASP.NET identity tables, and a custom application user. So this is the table that represents the data for each user. Now you can extend this and add more fields. Like if you wanted to collect other information about your user, you could add properties for first name, last name, things like that, other things, and they would go in this table. But we're going to leave it as is right now. We're only going to let people sign up with their email address. That's all we really need. So we're not going to make any changes to that. I am, however, going to add a database table for posts. So let me right click and add a class and call this post. And this table is going to have an ID, which I'm going to use a GUID, a created date, a title of a post, a description, the user ID of who posted it, whoever's logged in, and the navigation property for that user who's logged in. So if we want to get other information about the user, like their email address, etc., we can go navigate to it in Entity Framework using that user navigation property. Of course, to have this table be part of the database, I have to add it to the DB context. So let me open this back up. And over here, I will add it. So now that this table will be part of our database. And it will be as soon as I add a migration for it, because I have to migrate this additional table in. So let me go to the Package Manager console, and I will do add migration db1. And I'll do update database. This will add my post table to the database. Now, as a good practice, I'm going to actually add a repository pattern to this to allow access to this table instead of having my other objects directly use the Entity Framework code. So let me right click here and make a new folder for repository. And I'll add a class called the posts repository. Paste in the code. Now, you'll notice there are some errors here. What I've created is a data transfer object that I'm going to use to transfer data between my client and server. And I like to do this because I don't like to pass around the actual objects that are part of the data model. These are Entity Framework specific. I like to create other objects that match them roughly to use them to pass the data back and forth. So I'm going to have to do that. And how are we going to do that? Before I explain what this how this repository works, I'll go ahead and do this data transfer object. I'm going to need this data transfer object to be accessible from both projects. Now, the client project is already a dependency of the server project, but I'm going to go ahead and make another project called Blazor app2.shared, and I'm going to put the DTOs in there. So let me do that first, and you can do that by right-clicking and doing Add Solution up here. So I went ahead and did that, and now I have a class library project as part of my solution. And I'm going to just change this class object to be the DTO object that I was talking about. Post DTO. So it's similar to the entity object, except it doesn't have the navigation properties. And I'm not actually going to share the user ID with the client. I'm going to just share the name of the author. So this will be the email address of the author. So that's something I'm going to do as part of my conversion from the entity object to the data transfer object. But I have to change this to be post DTO. And then I have to add this shared project as a reference from the other two. So I can just, I'll do that. I'll add this shared project as a reference to the other two. I'll right click this and add project reference. Check this off. And on the client, I'll do the same. So now both of these projects can access this post DTO object. Now let's go back to the post repository. And I need to tell it where that is now. So using Blazor app2.shared, it will now have access to the DTO. Now we're also missing another thing. We need entity framework core for these entity framework methods to work. So I think that's all good. Okay. So let me explain this. This repository has 5 methods. I created an interface for it. This is going to be a service that we're going to inject in the server. So I created an interface for it and then an implementation. It's basically simple CRUD functionality on the database. This first one will retrieve all of the posts. The second one will retrieve a specific post based on an ID. Third one is going to add a post, but you have to tell it who you are, who's logged in, so it'll add you or the user ID of that person and make it their post. The fourth one is updating a post if you want to change what the post has on it. And then the fifth one is deleting the post based on the ID. So I'm going to go here and explain this pretty quickly because this isn't really a lesson on database, but it doesn't hurt. The service will have injected into it the DB context. That's all we need in this. This first method that gets all of the posts will simply, or this actually gets one post based on an ID. We'll retrieve a post object from the database where the ID matches that ID. And if it finds a post, it'll create a post DTO object. And it will copy the data from the entity into the post. Now notice the author, it has to do something a little different. It navigates to the user table and retrieves the email. Now there are tools, and I have another course on Blazor before that talks about this with the repository pattern and does automatic mapping and generic classes to do a lot of this in an easier way. There's a library called AutoMapper, which is very good, which will do this copying of the columns for you automatically. But just for the purpose of this tutorial, I didn't want to get into that kind of detail. So this is an example. So if it doesn't find it, it'll just return null. For this, we'll get all the posts. So it creates a result list. It will give me all of the posts in the table. For each one, it'll create a post DTO and add it to the result list and then return the results. For adding a post, we can take a post DTO in, this time in a user ID, create a entity post for entity framework, populate all of the columns. I make my own IDs in the table. I make GUIDs. And then I add it to the database and save the changes. And I return the ID of the new post. For updating a post, I just take in a post DTO, and that has the ID in it. So it'll look for the entity that has that ID. It'll update the updatable fields. Now, I'm not letting them update everything, like create date and all that, because that doesn't change. I'm only allowing them to change the title and description. So those are the only properties I copy over to the entity and then save the changes. If it doesn't find it, I return false. And deleting a post, I take an ID of a post, look for it. If it does find it, I do a remove and save changes. If it doesn't find it, I return false. So we're going to be able to use this repository object in a couple places in the server to provide the functionality that we need. And I'm going to go ahead and implement those next. Let me build it to make sure there aren't any errors. And so far, so good. I'm going to go ahead and create a page now where we're going to show the user interface that lists all the posts, allows them to edit, update, and delete posts, and add new posts. So this potentially is a page that I'd like to be rendered on the client using Webassembly. So since that is a potential, I have to actually put that code in the client project. And I'll add it to the pages folder. So I'm going to call it posts.razor. Now I'm adding it to the client project, but that does not mean I have to render it on the client. Remember, this server project has access to all of the objects in this client project. They're compiled in as well on the server, not just on the client. They'll be rendered differently, of course. So if you render it on the server, it's going to work a lot differently than rendered in WebAssembly. But this source code for this file is going to be compiled in both the client and the server. And this gets interesting because if you have code that's the same code potentially running on the server and running on the client, how do you know where it's running? Can it function the same way if it's running on the client as it's running on the server? Well, the truth is you can know, and you also cannot have them operate exactly the same based on where they are. So you're going to see how this plays out when I do this. And since this can be confusing, I'm glad I'm doing this example because I hope it'll help you understand the difference. So let me paste in the code for this page. Okay, I've pasted it in. There's a few problems I'm going to go over. But first, I just want to go over what this is. It's going to be a table, essentially, that's going to show all of the posts and have some buttons that'll let us update, delete, and or add actual new posts. Down here, we're going to have a list of posts. That's the data that we're going to retrieve from our database. We're going to have functions to handle deleting, updating, adding, and initialization. Now, there's a couple problems. I haven't created this iPost service yet, which I'm going to talk about. But first of all, we need the access to the post DTO, so I'm going to go to the imports Razor in this project and add a reference to the shared library, so that'll fix that. And now we just need to create the post service. So what is the post service going to do? We don't want to actually interact directly with, well, we can't interact directly with the database the way we're going to start off. Let me explain why. I have it here as rendering interactive WebAssembly. So this page, when we first implement it, is going to be a strictly WebAssembly component. So it's going to run entirely on the client. In order to get its data, it's going to have to connect to the server and get the data. And the way it's going to do that is through a web API that we're going to create to expose the data. So we're going to connect to that web API using this iPost service that we're about to create. So I'm going to create a folder here in the client called services. And in there, I'm going to put two files. I'm going to create an interface called iPost service. And I'm going to create a actual implementation called post service client. So let me paste that code in. I have to go back to imports and I have to use that folder as well. Client.services. Okay, everything's compiling. Let me go to the post service interface and I'll show you our service is going to have 5 methods. The functionality we need in our user interface is to be able to get posts, add posts, update, and delete posts. So we have methods for that. But I also made a method called onClient. This is just going to return a bool. You'll see where this comes in later, but we're going to be creating 2 of these iPost services. We're going to create one that's going to run on the client in the WebAssembly code, and we're also going to create one that runs on the server-side code. And they're going to share the same interface. And the reason they need to share the same interface is because they're both going to be accessed by the Razor page, post.razor, which could potentially be running on the server or running on the client. So they have to work no matter where they run. So we're going to have one that runs on the server and one that runs on the client, hence the interface. So that iPost service, initially when we create it, it's going to just run on the client because this is WebAssembly and it only needs to run on the client. So if I look at it, and that's what this version of the post service is, it's essentially just an HTTP client that's going to get for example, for this method, when you want to get all the posts, it's just going to do a get to an API that we're going to create that will get all the posts. On client, will return true because we're running on the client. When we add a post, we're going to do a actual post request, HTTP post, to that URL. When we update, we're going to do a put HTTP command to that URL with the ID. When we delete, we're going to do a delete command to that ID. So in order for this to work, we actually have to make an API on the server that will let this work. So let me do that. But before I do that, I'm going to actually run this service, because until you actually go into the program.cs on the client, this service will not be running. So what I need to do is I have to actually add two things. I have to add the post service, and I have to add an HTTP client. So this is a service that will allow us to access the HTTP client, which is needed by the post service. So these two things will start up the post service and start up an HTTP client. So if this page is running on the client, it'll use this version of the post service. Hence, I call it post service client. And we'll see it in action soon, but it won't work until we create an API for it. So let me do that. I'm going to create a controller in the server project right now to handle that. So right click, and I'll add a folder. I'll call it controllers. And I'm going to add one called a post controller. And this, I'll just add a class because I know I have a class to paste in. And that is going to be right here. Okay. So it's a standard MVC controller that has been around since ASP.NET Core. It'll access our post repository, which I'm going to have to create in our add to our program.cs in a minute. It'll have the post method to let you add, which will call the repository. It'll access who's logged in so that we can tell it whose post this is going to be when I call add post async on the repository. I will have the delete. If they do a delete request, it'll call the delete on the post repository. If they request just all the posts, it'll do that. If they request a single post by an ID, it'll do that. If it requests to update a post, it'll do that as well. This is not a tutorial on how web APIs work, but it's a pretty good example of a simple one. Requires them to be logged in, hence the authorized tag. And since this needs a post repository, I better create one in the program.cs so it's available. So let me add that down here to the services. And now we have a post repository available as well. Now we also have to see if the controllers are being added. So we have to add the controllers, and we have to map the controllers as well. Once the app is created, put that there. Okay. So let's see what we have. Everything is working. Now, there's not a way to get to our page yet because I haven't added anything in navigation. So I'm going to do that first. I'm going to add another item here. So that's located up here in Components under Layout in the nav menu. So all I have to do is I'll just copy the counter, and I'll say it's going to be at Posts, and I'll call it Posts. And I know that's the URL because the post.razor has a /post at the top in the page directive. Okay, so when this runs, it's going to load the WebAssembly for this page. And that WebAssembly is going to, well, let's see what happens. Let's actually see what happens before I make that statement. So I'm going to log in since this requires me to be logged in. And I'll do remember me so I don't have to keep logging in. And I'll go to posts. Okay. Notice it's looking for the post service as well. Now, we only created a client version of the post service. We did not create a server version of the post service. So that is why it's not working. So what I'm going to do is actually create at least the beginning of a server version of the post service too. Now remember, even though you think this is a WebAssembly component, and it will be a WebAssembly component, and I know that because I told it to be a WebAssembly component, what it does is it'll actually pre-render the page on the server before it starts up the WebAssembly component. So it has to be able to at least render itself once without interactivity on the server before it'll load the WebAssembly version of it. So we're going to have to create a service to run on the server as well because it's expecting it. The page is expecting a post service and it's using it down here, like it's using it in all these methods. So mind you, when it pre-renders on the server, it's only going to copy, or I should say execute this onInitialized async. So this is the only code that's going to run. In fact, let me comment this out here because we're going to see what happens here. So let me go and add the service, or add a version of the service to the server as well. So let me, in the top project, add a folder called services as well. And that I'm going to call post service server. So let me add a class here. And it's going to implement the same interface that the client version of it implements, because that is actually what we are using. Now it doesn't know where this is because I have to use the client folder. I have to reference the client folder. And I have to implement all of these methods. Now I can have it give me dummies, and the dummy methods will just say not implemented. So we can decide what we're going to implement as we go. We don't have to implement them all. If we intend for this to be a WebAssembly, the only ones we have to implement are the ones called by the onInitialized async, which in this case is getPosts async and onClient. So these two have to be implemented. Now, let me go ahead and implement those two. Or at the very least, I'm going to implement onClient. So this one I will change to be bool return false, because this is not running on the client, it's running on the server. And I'll make it public. So now what's going to happen, if I go to my posts, I'm going to actually change this a little bit. Right now it's trying to get all my posts. So when it's running on the client, I want it to go and get the posts from the server. Now there aren't any posts yet, so it won't get any. But on the client, if it's not on the client, I don't want it to do it. I don't want it to get the posts. So I'm going to put an if statement here. So the first line is going to be this. This method I implemented, so this is going to work whether I'm on the server or on the client. So I can say if on client, go ahead and get them. If I'm on the server, it's not going to bother. So it's just going to leave this list of posts empty, and it's not going to try to list the posts here. So let's see if this actually works in this state right now. Okay, it still doesn't work. And this is because I didn't register it yet. I have to go in the server, and I added my post repository, but I didn't add my actual service. So I have to have that as well as a scope service. Let's try that again. Okay, so I don't know if you noticed that, but it said client false, and then it said client true. So a lot kind of happened there without you knowing about it, and I'll explain what happened. If I go back to the code, you'll see here in post.razor, if I go here to onInitialized async, this actually ran twice. So it ran once on the server. So the first thing that happened on the server is it got this onClient variable, and from my service, it ended up being false. So since it was false, it didn't go ahead and load the posts. But it did go ahead and render all of the content of this page from the server into the web browser. While that happened, it downloaded the WebAssembly. So once the WebAssembly was done being downloaded, it actually reran the initialization, and in that case, it called the version of post service that's on the client, and on client was true, and it got all the posts, of which there aren't any, from the API on the server, and rendered the page. So let's actually use this page a little bit to put some data in. So let me run it again. If I go to posts, see it says false and then true. So the time that it was false, it was actually pre-rendered, and then when it switched to true, the WebAssembly kicked in. So it took a second or two. If I add a post here, I'll say test and test. The button's disabled. I have that for something other I wanted to show you later. Let me turn that off. So buttons being disabled, I want that to be false. Let me go back. Posts, false, you can see, and then true. So once it was true, it was WebAssembly. Now the WebAssembly is cached. If I go off the page and go back, boom, it goes right to true. It loads the WebAssembly. So it skips the whole step of pre-rendering on the server at that point because it knows it has it loaded already in the browser. So let me add a test post. And you can see what it did is it added to the table the ID, the author, create date, the two fields, and an update and delete button. So let me add another one and maybe a third one just so we have some data. And these other options work as well. I can delete one. I can update the text of one, etc. So we know it's working. And right now it's running in WebAssembly. If I leave the page and go back, the WebAssembly loads, and there it is. So actually you'll notice there's a quick little flicker. So there is potentially a little pre-render that occurs, and then the WebAssembly loads. But the pre-render is actually all happening on I take that back. The rendering is all still happening in WebAssembly. What happens is, when you first load the page, there are no posts. It has to use that API call to get the posts. So there could be a little bit of a delay for getting the posts, hence the little bit of flicker, because it renders the table empty, gets the posts, and then updates the table with the contents. So that's why there's a little bit of a flicker occurring here, which is normal because it has to get the data using the API. It's still fast. You go off the page and on the page, it's very quick. So once that WebAssembly is initially downloaded, it operates very quickly. Now, what if we wanted to actually make this a Blazor server component and not a Blazor WebAssembly component? Well, all we would need to do is change the render mode to interactive server. Now, the problem with that is, and I'll show you, is it'll work. But since it's running on the server, the post service that it relies on isn't going to do anything because notice it stays client false and there are no posts. I mean, there are posts in the database. Why isn't it showing them? Well, it's because if we go down to the code, it thinks it's running on the server, so this is false, and it will not load the posts. So rather than making that conditional, I'm going to take that off and let it load the posts. But our post service doesn't have an implementation for this. If I run it, I'm going to get a crashing issue because it's going to say not implemented. See, method's not implemented because I literally threw that exception myself. So what I have to do is actually go up into the post service on the server and implement these methods so that they'll work. And I'll be able to use that I'll be able to do that using my post repository like I did on the in the controller actually. I'm able to get the data directly from the database. Since I'm running on the server, I don't have to use an HTTP client to access the API. I can access the repository directly because it's running on the server. So I'm going to do that right now. I've pasted in a new version, and you'll see that the has a new constructor that takes in my post repository and the authentication state provider. This object will tell me who's logged in. Getting posts is just as simple as retrieving the post from the repository. On client is still false. Adding a post is the same as just finding out who's logged in and adding the ID and the post of that post. Deleting and updating are simply calling the repository. So it's an easy implementation because it can access the repository directly. So I'm going to see if this works. Let me start it up. And let me go back to posts. And you're going to see it came up right away, rendered on the server right away. There was no delay. It didn't have to download WebAssembly. It just ran. However, now there is a SignalR connection that is established between the client and the server to allow these interactivity options to work, updating, deleting, and adding. I could add something. I could go ahead and delete it. So we can see that it's actually working. It's not running on the client. So we have now created the Blazor server equivalent of this component just by changing the render mode. Now, it's also using the service on the server. So this is why you need to do all of the functionality in your page via a service with a shared interface if you care to have it work on the server and the client. And you're going to care, even if you do WebAssembly, it makes sense to, I think, do this because you may want to pre-render the page before WebAssembly gets access to it. So, for example, if I change this now to interactive auto, it's going to allow it to render as Blazor server first, download the WebAssembly in the background, and then switch to Blazor's WebAssembly once that's loaded. So let me show you what that does. Since both work, this should work. It should be able to automatically switch between the two. So if I go to my post again, you see it's not on the client, but boom, see what happened. A couple seconds later, it reloaded the page and it ended up saying client true. So what was running on the server using SignalR is now running on the client using WebAssembly. So that switch occurred on the fly. Now, it was a little bit awkward, I think, if you notice. Let me go back off the page and go back. Well, if I do that, actually it's not that awkward because it just runs the WebAssembly. But if I run it from scratch again, which is what your user will see when they first hit the page, is first the server version and then flashes, goes blank, reloads the data, and is now on the WebAssembly. So it's not really ideal, right? Now, the question really is, why is it flashing? And it's flashing because when the WebAssembly starts up, it doesn't have this data. It has to create an API call to go get it. So it starts up blank, gets the data, and then redraws itself. So they actually came up with a way to solve this problem. And I'm going to show you how they did that next. it's pretty cool how they solve this problem. They have this idea of a persistent component state. What this is going to do is, since the server is actually going ahead and getting this data, what it will do is when it renders the page, it's going to include the data in an encoded form that the WebAssembly can pick up, and it will have the data and not have to do the API call initially because the data will already be there. So let me show you how you do that. I mean, that's interesting. So if I go to the page, I have to add what's called a persistent component state. So let me inject that. And we also have to make sure that this class implements iDisposable. That's another requirement for doing persistent component state. Now we have to go down and add some things. So let me go here to adding a object called a persistent component state subscription. And we're going to create a few methods here. We're going to create a method called persist posts, and this is my method. And what that's going to do is save whatever the posts are, that we retrieve from the database into this application state. So anytime we want to, maybe we just loaded them, we can save them into this application state that will get transferred down to the client before it switches to WebAssembly. I have to implement the dispose method because I actually have to dispose of the persisting subscription object. So that's something I have to get rid of when the object goes away, hence the disposable requirement. Now our onInitialize is going to change a little bit, and let me do that. OnClient won't change because that's pretty much the same no matter what. But what we're going to do here is we're going to register this this subscription here, and what we're going to do is, does the application state have that data in it? So this is like, for example, when WebAssembly runs, if it doesn't find it, and actually it's really no, the first time this runs, the server's going to run, so it's going to see in the application state that post is not there. So it's on the server, it's going to get them. Otherwise, it's going to be able to retrieve them from this restored posts if it finds them. However, so when the server runs, it won't find them, and it'll put it in the application state. Now that application state will get transferred down to the WebAssembly before it runs. So when it runs, it's going to look for it. And if it isn't there, it will go get it, but it will be there the first time. So it'll actually grab it out of the application state instead of calling the API, which is going to slow it down to go get the data from the API and then create that flicker. So with any luck, this is going to switch without us seeing a flicker between one to the other. So let me try that, assuming I didn't miss anything. If I go to posts, false, true. Notice, no flicker. I'll go off quick. Now that flickered when I went back because it didn't do a server pre-render. It just ran the WebAssembly because the WebAssembly was cached. So it did a little bit of a flicker, but that's not a big deal because it's quick. But that first flicker that's there for when the WebAssembly is downloading is gone. So you'll see when I hit posts, it's the server rendered version, and then when it switched, no change, no flicker, because it was able to grab this data right out of that persistent state, application state that was transferred down. Now, there's one more thing I want to mention. And then when I start over, you'll see. During the time that page is, if I'm in render mode auto, which I am now, it's going to automatically start up in Blazor server, create a SignalR and all that stuff. and then 2 seconds later or whatever, it's going to switch to WebAssembly. So during this time, SignalR is running. I can click the buttons, but then within a second or two, it switches to WebAssembly, and then I can't. I mean, I can interact with it, but it's going to be the WebAssembly version. So since that Blazor server version is only running for like a split second, or I should say like a second or two while we're dealing with WebAssembly, I don't think I'd use the auto in this case. I think I would just use WebAssembly. Because what that's going to do then is during that initial 2 seconds, it's not going to bother creating a Blazor server SignalR connection and all that. It'll just show the table with the initial data, and then by the time the WebAssembly loads, it'll switch to that. So you'll see here, it showed it all, but it's false. But then true, it was able to switch to WebAssembly. So there is only one downside to that still. These buttons are still here. So while these buttons are here, in that 2 second period, the person would be able to update or delete or add another one. And that could be okay in some of your applications, depending on what kind of application it is. But in this case, I don't think I want to have that level of interactivity for 2 seconds and then have it all replaced. So what I'm going to do is actually disable the buttons if we're on the server mode. So I'm going to down here make the buttons disabled being the inversion of whether I'm on the client. So if I'm on the client, the buttons will not be disabled. If I'm on the server, the buttons will be disabled. So finally, when I run this, you'll see when I click posts, buttons are disabled, and then smooth as anything, it switches over to WebAssembly and the buttons are lit up, so it works. And of course, if I switch off and come back, the buttons are already enabled because we're already in WebAssembly. So I really hope that this example kind of gave you a little more of an in-depth understanding of how the Blazor server, Blazor WebAssembly, and the pre-rendering work. And hopefully this will help you when you develop more complicated programs. The standard template doesn't really explain a lot of this, so I hope this is helpful. And thank you for watching. If you like this video, please subscribe to my channel.